Okay, so we're going to review how to write exponential functions given a pair of points that it passes through. So the thing to remember about exponential functions is all of them are of the form a times b to the x plus k, where a is the value of, so k is the value of the horizontal asymptote, b is going to tell you the rate of growth or decay, and then a is, so it controls a few things, but I'm just going to call it the vertical stretch factor for now. It is very much related to the y-intercept and often is equal to the y-intercept, but not always. So this first problem, we're told write an exponential function that passes through 0, 16, and 2, 9. If we are not told a horizontal asymptote, then I am going to make the asymptote 0, because that's the easiest thing to do. So we're just going to let k be 0, and then we only have to deal with a and b. So I'm going to make k 0, and I just have y equals a times b to the power of x. Now, the reason they give us 2 points to do this is that each of these points is an x and a y, right? So this tells me that if x is 0, then y is 16. So 16 equals a times b to the 0. And it also tells me that when x is 2, y is 9. So 9 equals a times b to the second power. So because I have two equations and two unknown variables, I can solve for both variables. Now this, b to the 0, that always equals 1. So this is just a times 1. So this is the easiest version of the problem. So we could have skipped, because I know that the y-intercept is 0, 16, and k is 0. So in fact, the a value is the same as my y-intercept. Now that I know what a is, I can plug it in over here and solve for b. So 16 times b squared. And then I just divide and take the square root, and I'm done. Divide both sides by 16. So I have 9 over 16 equals b squared. Square root both sides. And so when you square root a fraction, you square root the numerator and denominator. So the square root of 9 is 3. The square root of 16 is 4. So 3/4 equals b. And then my function is y equals 16 times 3/4 to the power of x. All right, so second example. So this one gets a little bit more challenging only because we weren't given the y-intercept straight away. We weren't given the value of a straight away. So now I do have to, it's going to take a couple more steps to solve these two equations, but I set it up exactly the same way. And this process of plugging in for x and y, this is going to be common every time you solve a problem like this. So when x is 2, y is 18. And so it's still y equals a times b to the x, and I still don't have an asymptote given, so I can just set k equals 0. So when x is 2, y is 18. And when x is 5, y is 486. 486 equals a times b to the power of 5. So one way I can approach solving these is I want to solve for one variable in terms of the other, and then plug in to the other equation. And again, this is a strategy that works anytime you're solving some kind of system of equations. So here, now I do have a choice of which variable to solve for. I could isolate A or I could isolate B. But I think to myself, if I isolate B, and I'm going to write this down right now. Now, I don't want you to write this part down because we're going to erase it. But if I solve for B, I have to divide by A first. So then I have 18 over A equals B squared. And then I square root, and I have 18 over A square rooted equals B. And then I would have to take this and plug it in here. Well, no, plug it in for the other one. Plug it in for B, because I solve for B in terms of A. But then I'm going to have something square rooted to the fifth power. And I mean, that's doable. It's just, there's an easier way, right? Solving for B is one step, and it's always going to be one step because A is not the variable that is squared. So if I divide both sides by A instead, now this part you should write down, now I have 18 divided by A is equal to B squared. And that's much easier to deal with. So now I just take this and I replace the A in, or I replace the, oh, I did, sorry, I meant to divide by B squared. Divide by B squared, and I have 18 over B squared equals A. Sorry about that. So now this is an easy expression to plug in here and replace A. So 486 equals 18 over B squared times B to the fifth power. And because these are both variables in this equation are now B, I can combine these. So if I am dividing 18 by B squared and then multiplying by B to the fifth, so I'm just simplifying the right side of the equation, and you'll get to the point where you do this in one step, but we're going to write it all out. So when you multiply fractions, you just multiply numerator to numerator, denominator to denominator. And this, so I have B to the fifth on the top. So that's 18 times B, 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 B. There's 5 of them. 1, 2, 3, 4, 5. On the bottom, I have B times B. So when I divide here, and this is your simplifying exponents rules, 2 pairs of these are going to divide out to 1. So I'm left with 3 B's on the top. So this is a B cubed. So I have, this is still 486. So 486 equals 18 times B cubed. And then just divide and take the cube root. So 486 divided by 18 is 27. And then take the cube root of both sides. And B is equal to 3. So I still don't know what A is, but conveniently, I already solved for A in terms of B. So I look back here, I have B equals 3, and here I rearranged and I said 18 over B squared equals A. So I just use that to get what A is. So 18 divided by 3 squared equals A. That's 18 divided by 9, so then A equals 2. So my equation is 2 times 3 to the power of x. All right, so the last one, now we're going to do one that has a horizontal asymptote. So the only thing this changes about the equation is that now we have k equals negative 4. So I'm going to write my two functions, or my two equations, using my x and y. So when x is 2, y is negative 8.5 to the power of 2. But there's a minus 4 on both of these equations. And my other equation is negative 166 equals a times b to the fourth power, also minus 4. And this just adds one step to the problem because I still am going to try to isolate one variable and solve for the other. But both of these equations, I'm just going to add 4 to both sides. And now it is exactly like the previous problem, right? Negative 162 equals a times b to the fourth. Now we just solve it like we did the other ones, right? You'll notice I'm going to pick this one to solve for a, just because the numbers are smaller. So divide by b squared, and I have negative 4.5 divided by b squared is equal to a. And I take that expression and I replace a here with a negative 4.5 over b squared. Times b to the fourth. B to the fourth divided by b squared is going to be b squared. So negative 162 equals negative 4.5 times b squared. Divide by negative 4.5 on both sides. And we get 36 equals b squared. So b is 6. And then I just, same thing I did on the last one, I can plug in here and find what a is. So negative 4.5 divided by 6 squared equals a. And that is negative 0.125 or negative 1/8. So then there's my function. My a value is negative 0.125 times 6 to the power of x, and not forgetting that I have a minus 4 for the asymptotes. All right.